Hello everyone, I'm Sumant Kakarparthi, Principal Product Manager for IWAN. So today we are going to talk about application visibility, protection, and optimization. Take this. So when it comes to application visibility, the fundamental principle is you cannot optimize something unless you actually learn something, right? Unless you actually measure, you cannot actually optimize it. Anything that in a broad way applies to life too, in terms of as long as you can't measure, you cannot improve. Right? So that's where the visibility part comes in. So from a visibility aspect, we have multiple technology stack in terms of like how you gain visibility, right? Visibility will have two things. One, classify, and two, you actually measure. So when it comes to classify, what we use is N-bar2. And the most important thing is N-bar2 has multiple ways to actually classify the application that are running in your network. There are 4 different ways. Actually 5 if you include the port-based thing, right? Because this technology is there and we actually evolved a lot in terms of how you evolve your classification. You can classify based upon a simple port-based classification, doing that used to work earlier, but now HTTP is the new TCP, right? The second key aspect what it can provide is it can provide a deep packet inspection. It can look beyond the port numbers and it can actually look at layer 4, layer 7 and say like what is the application that it belongs to. The third aspect is really about what we call it as custom applications. On the custom applications, let's say you have your own applications, whether it is transaction or so, or your own point of sale kind of applications, very custom to your own enterprise, you can actually define those applications. And the fourth one is what we call as protocol packs. So protocol packs is every 3 or 4 months we actually release some new signatures for you to download without any iOS upgrade, right? And we'll be automating that through the controller. And the reason why we need it is if you look at rogue applications like BitTorrent, it's a cat and mouse game, right? They keep changing their signatures and we keep updating the signatures and they keep changing the signatures again, right? So we actually try to release new protocol packs for these rogue applications so that you have up-to-date information on these rogue applications and you can actually throttle them or you can take the necessary action. So you can do that even today without updating your entire iOS. You can just load the new protocol packs. And the fifth option is really what we call it as app fingerprinting or what we call it as DNS-based classification. We can look at for public cloud applications like Office 365 and so on. We can look at the DNS requests and replies and then get that application information from it. So N-bar as a whole, N-bar did not change. We are using the same name. But what changed is the number of techniques that you have within N-bar to actually classify this whole wealth of application information. Once you classify, measurement becomes quite easy. On the measurement, what we use is what we call as performance monitoring. The first aspect of performance monitoring is to identify where the problem is, whether it is client side, server side, or on the network side. So the first thing it does is do a macro level monitoring, which actually tells you, breaks it down to segments, saying client versus server versus network. That's the first level. The second step is if it is in a network, then break it down into more detailed information saying, hey, I need, whether it is jitter, packet loss delay, or so on and so forth, right? So enabling this monitoring is done by what we call as performance monitoring. PM. So this N-bar2 with performance monitoring together provides you a complete full picture of visibility. And this is actually very powerful because you are actually doing this, to your earlier question earlier, you are doing this passively, right? You are actually enabling this on the routers passively. You are getting these metrics. You have a policy in place, and then once you see the metrics, you see the data, you act on it. Earlier, that used to be administrator used to act on it based upon that, but now the network can actually adapt to that based upon those metrics. So this is really a foundation pillar for us.
When I'm building a policy in APIC EM, and I've got those drop downs of all those different applications,
yes.
What I'm actually looking at is an NBAR2 library.
That is correct.
Okay, so that's going to match up with what I'm seeing on the router.
Absolutely.
So I'm limited to what NBAR2 can see as far as application classification?
NBAR2, as the techniques actually change, the name is NBAR2, but you can actually, NBAR2 right now takes custom applications, right? So let Pedro actually show this. It's a good timing that you actually asked it. So Pedro, can you create a custom application? Let's call it as Cisco Mail, new collaboration.
So we, as Suman said, we have the applications that we know of, the most common ones, but everyone ends up having custom applications. So if you have, let's say, a mail service from Cisco here, and then this mail is identified by URL, port, or the HCP. So let's say that I would give it a server port based, and I make it like Office 365 and goes in my business and productivity. So in a few steps, identifying this by server, the threshold crossings that are available and are similar to another application, I'm going to add this application and it goes in my business productivity. So now it shows up here in my business in productivity, my new custom application.
Pretty simplistic identification though, right? Just port numbers, IP addresses. I can't do any deep packet inspection there, right?
Deep packet inspection, NBAR has already built in deep packet inspection.
But as far as custom defining an application?
For the custom defined applications, I think you can have protocol packs.
We can match with the domain name, that is some of the new things. So we can match the DNS. Here. Yeah,
So
we can
these,
match with
will these apps, will they export Netflow data as well?
Very good.
And all
So
that?
everything that these apps are actually, one, the visibility aspect of it, understanding the application name and stuff, and also the monitoring aspect of it. Everything is done based upon Netflow v9 and IPFix.
Okay.
So the interesting part here is the controllers actually consume this data to actually make the right decision in which link to take. And the same data is what you will see it in. Let's say you don't enable path control. And it's the same data that you will see on a visualization tool.
Okay.
Whether it is any of the partners or our own Cisco Prime can actually consume the same data and show you exactly which path it took. It's based upon Netflow v9 and IPFix.
Okay.
So everything is actually based upon the same thing. So there is no two different formats for controller versus something else, right? It's all Netflow v9 and IPFix.
You mentioned HTTP is the new TCP, fair enough. Encryption, a lot of those HTTP payloads are encrypted. What does that do for NBAR2 and deep packet inspection?
Absolutely. So that's where I think the fifth technique that I mentioned regarding looking at DNS information and then actually identifying them. If it's an encrypted application, identifying them will help you to classify like Microsoft Office 365 and so on and so forth.
If it's my internal app and I'm trying to optimize internally, I don't have a DNS lookup to reference with that kind of information. Does NBAR make any inferences about the payload if it's encrypted? Or can he really only see into layer 4?
So we can look at the unique name of the certificate exchange. We can match with it and create a custom app for those internal encrypted apps. That is one option. For the cloud-based encrypted apps, again, we look at the certificate exchange, so we can detect all those encrypted cloud-based apps. For internal apps, we can match with the unique name or server name. That way we can classify that.
How about like a port? I mean, I don't know how important this would be, but like a portal, like if I'm building all these different, custom apps and all that, and, somebody else may not really know everything about it or whatever. I mean, obviously it was pretty simple to set up, but I mean, are you going to have a portal? Is there a need for it, any requirement for it, or?
Yes, so there is There is one portal that we will actually share with you during the full-blown at the end-to-end demo, where you will have a single pane of glass. I think to your point, single pane of glass to actually see all the applications and different categories that we actually put these applications.
Okay.
And during the SD-WAN, one of the critical aspect when we talk about applications is because typically there are around 500 to 700 applications running on your network. You don't actually individually add policies to these applications. What you want to do is you want to group them in terms of what it means to you for your enterprise. Let's say take Facebook. Facebook generally by default will actually group them into social networking, right? But if you are Facebook, it's not social networking, it's business and productivity tool, right? So you will actually regroup them. So application identification, we have a whole stack of things, what you can leverage to identify the application. The most important is the application grouping is what the customers will do, saying like, what is it that will constitute as my business critical versus recreational, right? It really depends from business to business. Okay.
So when you create these custom applications, are they, and this is my ignorance of NBAR, but are they pushed out to the branch as well, and NBAR is dynamically updated with the new definition so that your branch devices can recognize that custom app?
Absolutely, absolutely. So that's again goes back to this principle, right? So for the simplicity and agility, if you really want to enable a new app, what you don't want to do is like have multiple touch points to do that. So with the one that actually Pedro enabled, even if you have 2,000 or 10,000 devices, really doesn't matter. All the devices, all the network elements will get the new policy, new definitions, right? So that part we are very serious and say like that has to be centralized. You cannot keep on doing this repetitive task of redefining the network.
And can I choose which branches don't get certain definitions, or?
So you will have some,
really
yes,
matters.
you will have customization where what we call it as segmenting it out, saying that I will create a profile that actually says that branch A, B, C belong to this profile and they get a different policy, right? There are particular business drivers for it. If you actually did some acquisition, you will have a different policy for each of these profiles or different segments, and you want to have different policies. And we have the same case with respect to, hey, for employee, guest versus partners, right? The policies will be different because for sales, it's voice is more important. For engineering, it's something else that is actually more important, right? So you can define that. The way how we drive that is creating these segments or domains, what we call as, and each domain can have a separate policy.
Real quick, we were talking about the
please.
UI a little bit ago. I'm curious, do I need to install Flash or Java to use APIC-EM?
No, you don't.
Thank you.
HTML5.
Rock on.
No Java.
No Java.
No job. All right. Let me erase this. Let's talk about, since we got the visibility that we need, now let's talk about protection of these applications, right? So that's where SLA protection comes into play. And I just want to give you a policy picture of it, like how we do it. So let's say you have 3 applications, right? 3 applications, and each of these application in a way belongs to their own group, right? So you have WebEx, which actually is your voice and video, and you have Cisco email, which is your email group, and the other one is gaming, right? You just don't want to be too strict, but you just want to allow it if it's okay, right? Now in the Valley, I think it's okay to play video games. So, but you want to have different policy for each of them, right? For WebEx, it's actually simple. So if WebEx, I can say, hey, go, MPLS is your preferred path, right? MPLS is my preferred path, and then if the SLAs are not met, 20 millisecond SLA is not met, use internet, right? So start with MPLS. If all things are equal, start with MPLS. And for email, you can say, use MPLS as my preferred path, and then if SLA is not met, try to use 3G, 4G, right? It's not really jitter sensitive, so just use 3G, 4G, I have enough bandwidth on it. So you can have a policy for that. And the third aspect is, you have gaming. And this is actually interesting, because gaming you don't want to be way too strict, saying that nobody plays any games ever. But you just want to have a policy that says, okay, if there is additional bandwidth, then just use internet for gaming, right? And if let's say the internet link goes down, you don't want to put gaming on your MPLS link, right? Because that is where the business is going on. So what you say is, hey, for gaming, use internet as your option. And if internet goes down, you want to drop it. Doesn't matter, because that's all you are going to give. You will actually have 1% of the queue or so on for gaming, and if a circuit goes down, you will drop that gaming, right? So when it comes to SLA protection, it's not about one size fits all. You can have a custom defined policy depending upon your business needs on what you can do for each of them, right? And the most important thing is, to your earlier point, is you want to make it a single touch point on how you administer this policy. So Pedro, can you show like how I can enable this policy with WebEx, MPLS as primary, and internet as backup?
That's right. So if you look at, let's say, the voice and video application, right? Very common one. So within this category, right now I have no application performance preference, meaning that I will actually load balance across the links. But if you really want to use your primary as so we do show you all of your options here. My primary is going to be my MPLS, and my second path is going to be my Comcast in this case. Then this now actively will run all of the voice and video applications within this preferred path when available, unless we have a brownout or a blackout situation with that link.
The second one is email. Can you put email on MPLS and backup as 3G?
Exactly. So you can also do the change where you can run email, for example, on internet, and then decide to use 3G as the second path preference there.
Gaming, let's say I just want to use internet and then drop it.
So the other option is to drop, right? You can always set just one path, but then if you are, again, a blackout situation, don't even move it to a link that it's business related, so just drop the traffic. So it's as easy as this.
Now, can I add more paths?
Yes.
Customized?
That's right.
Okay.
Yes. So you will see particularly more and more paths. I think the earlier version supported up to 200 WAN paths. We don't know why we kept that limit, because nobody has 200 WAN paths. So now we said, like, okay, that's not needed. We can actually by default we can support up to 5 WAN paths if that is required, and that's the most that we see in terms of number of WAN links and so on, right? Okay.
Are there alerting options for when those rules are triggered?
Sorry?
Alerting options for if those rules are triggered. So if there is a failover to the secondary path.
Okay, so good question. I think the hierarchy of them is that a right way to say that?
Sorry?
You are talking about a hierarchy of the WAN paths that you want.
Yeah, just an alert that if one of those rules is triggered, that if the primary path is unavailable and you're now going over the secondary path, that somebody gets notified that that's happening. I mean, assuming
Absolutely.
You have other tools in place to let you know that your MPLS is down.
Sure, absolutely. So coming back, this is 20 milliseconds. That's the SLA, because the SLA is actually inbuilt, as you guys see. Any application that you select, automatically it comes with the SLA inbuilt. Like if you don't like the SLA, you can actually change it. So once you have that, you can set the path preference saying MPLS, and the MPLS goes down. That's the first step, right? When I say going down, it doesn't mean you have to lose the connectivity, right? It's a soft error. Let's say the MPLS now is 100 milliseconds, right? The delay is 100 milliseconds. It immediately goes to the next best link. It monitors as we monitor the SLA on internet link. If it is 15 milliseconds, I'll just move it to here, right? If the internet goes down, then I can actually monitor this and then move to 3G, 4G, or any other WAN circuit that you need. So you will have an option to actually set the preference in terms of, hey, if this link goes down, go to the other links for a particular group. So you can do it on a group basis. And for email, you can just say use only 2 of them. For WebEx, use all of them, because it's very critical. Doesn't matter if I'm getting charged when I'm using 3G, 4G link, but I need to have the survivability of WebEx application. Please go ahead.
Are there policies on going back to the primary? Are you testing to see the primary if it goes back to an SLA state that's acceptable?
Absolutely, very, very good question. So with respect to policies, so there are multiple ways. One of the things that we did not show you, and we'll probably cover that in the demo, is you have an SLA, you don't have to select a path preference, right? If there is an SLA and there is no path preference set, the only rule of thumb is make sure that find a link that actually delivers on this SLA and then assign it. The other option is you make an explicit choice that Pedro showed, saying, hey, I want MPLS preferred over internet, right? So in that case, if there is a problem with MPLS, we actually move to the internet circuit, right? But once the MPLS is back and healthy again, we move back. Then the immediate question comes up, and I'll give you the follow-up question, is what if you can oscillate and you can flap between those two links? It comes up and so on, right? And this is exactly what we do to actually avoid it. So the reaction, the first time when we do mitigation, we do it in sub-second, and we do it for the jitter and so on, we do it within 2 seconds, and then we react to that. So that's one. But however, moving back to a healthy link, we don't do that immediately. And on purpose, we don't do that immediately. The reason is we actually keep monitoring that link, because we lost trust on that link. Until we regain the trust, we don't move back the application. So for the next, I think by default, we actually monitor that link for 180 seconds, making sure, not just from a connectivity point of view, from an SLA aspect, that the link meets the SLA. Only then we actually move the application back to the original link. Your preference will be honored. So it's really, once you lose the trust, you will wait and you will see if the SLAs are back to normal, and if it's like really, really healthy, only then you will actually move back. You will definitely move back, but you don't move back automatically. Like once the link says I'm healthy, you don't trust it again. You actually keep monitoring until you regain your trust and then move back. Please.
I was going to say, in a failure scenario, suppose you've got gaming on the internet,
okay,
and something more important needs to fail onto the internet, but there's not enough bandwidth, or can you bump something out of a particular transport option,
yeah,
in preference for something more important, more business critical?
Very good point. So I will actually show you. Okay. So Pedro, so gaming is actually consuming too much video. What can I do? Or too much bandwidth. What can I do?
Well, so here we have the option, right, as we say, drop. So if we don't want it to use any of the additional links, because the links are used for something else, we can say drop the traffic. So you actively drop the traffic.
Sure. And most importantly, if you see, gaming is actually in a category called scavenger. The scavenger class is really about you are giving 1% of the bandwidth. Right? So if, let's say, there is another application, file sharing, right? File sharing, you don't want it. So Pedro, can we move file sharing to scavenger? So what happens here is, once you do this move, on all your network elements, there are a couple of things that are happening in the background. Your DSCP marking is changed. Now CS1 or whatever the provider actually gives you, saying provider says scavenger is CS1, you actually you did a remarking to actually match to CS1. And second thing, you actually change the bandwidth, they throttle the bandwidth for gaming to 1%, right? And this happens, the thing that Pedro actually did it, triggers the change on all the networking elements connecting to your WAN.
That's pretty cool.
Yeah, please.
Looking at the business applications, if there are issues, so, if a backup job is running and there's a bunch of WebEx happening at the same time and I'm running into SLA issues, can I also decide which of my priority applications gets bumped first? So I want to keep backup on MPLS and move WebEx to internet.
Absolutely. So the way I will tell you the logic in terms of how we are actually doing it. So within a site, this is really about what we have is about application groups versus the bandwidth that are actually consumed, right? So if you have voice and video, you can actually set the bandwidth that is actually assigned to this voice and video class. Once you set the bandwidth, let's say you within the business, the question is more like if it's scavenger, it's very clear, you get 1%. But if within the business, you will have some default assignments, you can actually go and change it, saying that for now, for the time being, let us make it 80% instead of 40% or so on and so forth. So you will have that single pane of glass to actually say, how do I actually switch the bandwidth from 40% to 80% in the meantime, right? So within the business class, business critical group, you can actually change the bandwidths. And that part is actually going again to our basic principles, right? We centralize that part of the equation, saying that we'll let it happen in a single pane of glass in one touch point, and then we'll propagate it to the routers. Please.
IPv6 support for application identification. IPv4, we've talked about, I've seen it on the menus. What about IPv6?
So IPv6, so today, I think the classification and the monitoring is actually already supported for IPv6. There is pieces of path control that we are actually adding for IPv6 support. But when we actually release, when we actually enable it, and one of the reasons that you did not see that on the user interface is we want to make sure that you have an end-to-end support, not just on the performance monitoring, which is already there today, but we want you to offer that when we have the complete stack. Performance monitoring, path control, optimization, and security aspect of it. If all these pillars are supported, that's when we'll actually expose it to GUI, saying that you can do IPv6 support.
So I'd actually like to expand on that, just
sure, please.
Way above application inspection. And I'm just speculating here, but I saw a lot of similarities, specifically the Ask Me Anything bar at the bottom with the Meraki solution. So I don't know what's been shared there, but we haven't had a great IPv6 story from Meraki in the past. I'm curious, just from a total general product perspective, will anything break if we have essentially an IPv6 only network? Is it a comprehensive IPv6 supporting product is really what I'm asking.
Absolutely. You will have a comprehensive IPv6 support. Even if you look at transport today, we support dual stack. You can actually change the overlay. You can actually have a dual stack, and you can also do the monitoring today. You can just enable the monitoring aspect of it without breaking anything.
So like I can put in a v6 syslog server, for instance. That's not a problem.
So with the v6 syslog server and also even the monitoring aspect of it. So the things that are actually missing is on the path control, we are actually making v6 support. Mm-hmm. Once we have these pieces together, again, this goes back to our basic IWAN principle, right? When we started it, we did it a little bit different from the traditional approach that we used to take, right? We did not say that there are capabilities A, B, and C, and then go figure on the scale, performance, and stuff. Mm-hmm. So anything that we are doing, and this is very important because I'm glad you asked, even within Cisco, how the teams are there, how the validation is done, it is done as an end-to-end solution use cases, right? So what it means to the user is obviously you will get good CVDs and validated design. What it also means is the performance and scale numbers. I'm not giving you just crypto numbers on ASR 1K. Right. When I say I'm giving you IWAN solution numbers, I'm giving you end-to-end use case of enabling hybrid WAN and so on, end-to-end use case numbers, which will actually include performance, scale, and the interoperation and the integration of these technologies, everything together, right? So that approach, something that we transformed over the years, saying like we want to move away from saying this technology can scale X and that technology can scale Y. It really doesn't matter. When we actually put everything together, the solution scale is what is important. So when we do, that's exactly the reason why we do not say like, hey, use IPv6 right now, because we don't want to do that. We will do that when we actually say this is the CVD, everything with IPv6 is automated. Don't worry whether you are using monitoring, path control, or enabling every use case. Everything is supported. We'll come up with a very prescriptive and very clean way to actually say that we are IPv6 support.
Okay, cool. Thank you.
So you've talked about some of the, I don't know if it's fair to call them reactive things that the solution does in order to detect that an SLA has been broken and then fail over to a different link. There's obviously quite a number of you in the SD-WAN space or hybrid WAN space, depending on your preference. Sure. or flavor of whatever. Some of those other solutions are looking at more proactive things as well. So they're doing things like advanced error correction techniques to try and get across lossy links or corrupted packets. Some are looking at sending duplicate packets over multiple links to try and make sure if there's packet loss that one of them gets there, right? Is that something that you guys have looked at? Is that something you're likely to support, or do you just think it's a ridiculous idea and therefore it got dismissed? I'm just curious because from a sales perspective, it's a very compelling argument to go, hey, I can magically fix problems, right? That don't just involve moving to another link, which could also have packet loss and may not be ultimately much better than the last one.
Your point is spot on, and there is something that is real with that I want to address in terms of these methodologies, and something which is like making it more engineering rather than addressing a problem. And I'll be brutally honest on that. So today, the things that we incorporated, let's say I need to use my stickers again, a new WebEx flow is coming, right? The first thing is we don't actually blindly put it on a link. Before we do that, we actually have a complete set of data in terms of how the SLAs are doing. And we actually do that monitoring, whether it is jitter, packet loss, depending upon the service provider marking. So before we even start the flow, that's what I said, it's best of best link to begin with, right? We know the SLAs on the link, that's one. And the second aspect is reacting to that. Reacting to that, it's yes, the current link is having a problem, but I'm not actually saying because the current link is having a problem, let me move to another link, because that doesn't work, right? Sure. Because I don't know how the other link is doing. But in IWAN, what we are doing is, that's where I said the smart sensing kicks in. Let's say that you have only one voice flow going through your MPLS network, right? And on the internet circuit, we actually generate synthetic probes just for the voice to actually simulate and get the SLAs, right? So if I'm making a decision of saying I will move from MPLS to internet, I'm making a very educated guess saying that I know that based upon the data in this second, internet is actually doing much better. That's why I'm moving it. So I'm not moving the flows blindly saying I will move and I'll pray. This is a very educative way of saying that I know the SLA, that I'm getting it dynamically and I'm adjusting it. If the SLA is even worse than that, then I won't move it. Even if I have a violation on MPLS, let's say it's 30 milliseconds, what about if other link gives me 100 milliseconds? So I have that information in the global table to actually make that decision. So there are other things that you pointed out in terms of every packet actually sending it, duplicating on a packet-to-packet basis and stuff. I think 3 years back when we actually floated this idea, customers absolutely hated it. It's not because it's not cool, it is cool. But the thing is the challenge that gets involved with respect to troubleshooting. Now, if the reordering and all these variables that we can that gets inserted when we do a packet by packet basis. I'm saying like, let me send this packet here, this packet over there, and then you are for particularly in elastic media like WebEx or telepresence and stuff. So the more and more the applications are getting more sophisticated and becoming more inelastic, this gets magnified in terms of yes, it will have some value, but versus what you are actually trying to solve, it will lose the bigger picture.
Right. I can also see it's not an existing protocol that you can plumb in. It's more of a custom solution you've got to build into the code on every device.
Correct. So the reporting, if you think about it, if you go down that path, the reporting, let's say the application suffered. Right now there is no deterministic way of saying you will be doing debugging at a packet level, saying this packet went to this path for some reasons and the other packet went to this path, and for some reasons these two packets got dropped and so on, right? It becomes more and more hairy in terms of once you start troubleshooting it and debugging it, right?
Well, and I guess the hope is that if for example you send duplicate packets in the hope that the end result is you see minimal loss at the other end, then you won't want to troubleshoot it, right?
Yeah.
Other than you have the stat that I've got 20% packet loss on this link, the hope is the application doesn't ever get to the point of degradation where you have to step up and say, oh, let's figure out why this is dying, because it's kind of worked around for you.
Absolutely.
Which I don't know how other people feel on it, but I like the concept of something that just fixes stuff and just works. Alert me, sure, but just fix it. Anyway.
So we are doing something called predictive analysis. We'll definitely talk about it, where instead of doing a packet by packet distribution, we learn the patterns in the network, and then depending upon the time or the events, business events that are happening, we actually find out the optimal paths to take. We are approaching that problem. We are trying to deliver the same end result that you are talking about, but in a different fashion rather than just doing a packet level redistribution, understanding the packets at a macro level, understanding the patterns at a macro level, and and then finding the right path.